The part of continuation about the shapes of orbitals. Here, according to these notes, they have described well compared to those I used in my past video. Now, each type of orbital has its own shape, and these shapes are determined by the azimuthal quantum number. The size of these orbitals increases with increase in principal quantum number. So the shape of the orbital remains the same, but the size increases with increase in principal quantum number. This means that as the principal quantum number increases, the region with a high probability of finding an electron becomes large because the size of that orbital increases. Now, the s orbital, L will be equal to 0 as spherical. P orbital, which is L is equal to 1, each with two lobules with dumbbell shape. So the shape is called dumbbell shape. These orbitals have identical energy, shapes, and size, but differ in their spatial orientation. Hence, they have degenerate orbitals. Now, they have the same shape, size, but differ in their spatial orientation. So they are called degenerate orbitals. So if you are asked, degenerate orbitals are orbitals with the same energy, shape, and size, but they differ in spatial orientation. There are 3 p orbitals, each with 2 lobes with a dumbbell shape. Their orientation are distinguished by their subscripts x, y, and z, which represents the 3 axes in the space. By using block diagram, the p orbitals can be represented as. So here, let me edit a little here. So let's proceed. Okay. Now, by using block diagram, the p orbitals can be represented as you can see here, px as 1 box, py 1 box, and pz 1 box. So that is what we call the block diagram. The orientation are designated as px, py, and pz according to the direction of maximum density. When these are superimposed, they end up in space enclosed by spherical shape. So all these p orbitals, they have dumbbell shape, but when they something like arranged together, they end up in a shape which is spherical. So there are 5 d orbitals with L is equal to 2. 4 of these orbitals have a similar shape. They have 2 pairs of dumbbell shaped orbitals. The orbital designated as dz square appear to have 2 as around a pair of dumbbell. I hope if you look from my first video, you saw how these appears, how all of these d orbitals, p orbitals, and s orbitals they appear in diagram. Naming of degenerate orbitals is based on the orientation of maximum electron density of the orbital. For dxy, dxz, and dyz, the regions of maximum density point to the plane indicated by the subscripts. So, if the region of maximum density of electron is towards x and y, that's why we call dxy, or dxz means the region of maximum electron is along x and z, and etc. The dx square minus dy square and dz square are centered on the coordinated axis. Dx square minus dy square is centered at the xy axis, while dz square is centered at the z axis. As p orbitals, when the degenerate d orbitals are superimposed, they end up with a space enclosed by a spherical surface. Now note, S orbitals are spherical in shape. So that's all, and this video is very short. My aim was just to increase or to expand your knowledge on orbitals, but let me add something in your brain that about these orbitals, they just ask about shapes, and you must know about these quantum numbers. So just like that. Thank you. Have a nice study. Remember to join my Telegram group so that you get notes. This is according to the notes labeled as General CH2, and they are in doc. Thank you, everybody. Nice studies.